Hey, welcome back, Kalyan.
Hey, thanks, Duncan. Thanks for having me. I've been looking forward to this, so I appreciate you having me back on.
Yeah, it's been a while. It was actually episode 59 from the top of my head that we had you on, but some of the listeners may have heard the episode back then, but for those who haven't, it's probably good to introduce yourself. So, who are you and what do you do for Broadcom/VMware?
Sounds good. Yeah, I didn't realize it's been back episode 15. I think you're at 112 or something now, so I'm glad to be back again. But anyway, my name is Kalyan Krishnaswamy. I joined VMware just under 9 years back now. A variety of field-facing roles originally before I transitioned into the product management role. And within product management, of course, we are a team of folks that focus exclusively on vSAN. And I have sort of my primary area of focus is around vSAN storage clusters, which is what we're here to talk about, which is essentially our disaggregated storage offering. I manage an entire portfolio. But secondary to that, I also manage clustering on vSAN, running any sort of clustered applications on vSAN itself. And lastly, and probably just as importantly, working on some significant networking enhancements within the context of vSAN itself.
Yeah, we'll make sure to actually get you back on the podcast when some of those new networking enhancements are going to be released, because I'm sure that the listeners will be very excited about it. Now, you've already mentioned it, vSAN storage clusters, but last time you were here, it was still called vSAN Max. So it is probably good because it has been a while if you can introduce what a vSAN storage cluster more or less is, so the audience kind of has an idea for those who haven't actually looked into it.
Absolutely. Yeah. So I know this has been some source of confusion, but back when we announced vSAN Max in, what was it, late 2023, August of 2023, our world was a little different. The licensing model was significantly different than what it used to be. And we wanted to, at that point, for that reason, we had a branded product as a separate product with its own SKU and its own licensing model. Fast forward now, of course, with this new simplification of VCF constructs and VCF-based licensing model, there's really no need for it, and vSAN being part of that VCF licensing model itself, there's really no need to have a separate product, separate SKU, but instead, what it becomes is just a vSAN storage cluster, or what was called vSAN Max, just becomes a deployment option within vSAN. So it's really simplifying, leveling the playing field from a customer perspective, letting them choose their deployment model based on their requirements. But just to quickly recap what vSAN storage clusters is. So, first, of course, you talked a lot about vSAN ESA in your podcast. The innovations in vSAN ESA allowed us to provide a fully disaggregated storage offering. And that's what is now the functional name is called vSAN storage clusters. We moved away from the branded name. But branding aside, there's essentially no difference between these two. Of course, we made significant enhancements in functionality and features with storage clusters since we originally announced vSAN Max, but functionally they're effectively the same, providing disaggregated storage offerings for our customers. And at a high level, what that means is you have a separation between compute and storage as opposed to HCI, where it's all collapsed into a single deployment model. Providing storage resources for both HCI-enabled clusters and for compute-only clusters. And again, going back to what I was saying, it really depends on customer use cases, whether they want to deploy HCI or DHCI. But the beauty about this platform is it's operationally identical from whether you deploy HCI or DHCI environment. Anyway, that's in a nutshell what storage clusters is.
Yeah, that makes sense. Now, one of the things, of course, that people are always interested in, and it's one of the things that I'm also interested in hearing from you, is why would people do this in the first place, right? What is the use case for doing a vSAN storage clusters? I mean, I've heard various use cases popping up, but you've probably heard many arguments for doing this. So maybe you can explain what some of those use cases are for adopting a vSAN storage cluster.
Sure. At the most fundamental level, again, going back to what we discussed earlier, at the most fundamental level, vSAN allows you to disaggregate compute and storage. So deploy compute and storage independent of the other. Not dissimilar from how traditional storage is deployed. Your traditional three-tier architecture is deployed where you have the compute layer, you have some sort of fabric, whether it be fiber channel or IP, and you have the storage layer on the other side. So what disaggregation brings is essentially that. And by that, what that affords the customer is to scale one independent of the other, which is a huge deal for customers. If you think of applications that's running on the HCI environment, if a workload requires more storage, you're implicitly scaling out the compute as well, and vice versa. If your workload requires more just compute, you're implicitly scaling out storage, which might not be ideal for a lot of these workloads. It could be cost prohibitive. So if you think about now within the context of disaggregation, customers can deploy this independent of each other, but also scale one independent of the other. If a workload requires just more storage, all you're doing is expanding your storage cluster either up or out to satisfy those requirements. Another inherent benefit with doing this sort of disaggregation is lifecycle management. Of course, if you think about it within HCI world, lifecycle is all integrated, it's all simple, it's all done at the same time. This might not be appropriate for a lot of customers where they want to perhaps only a lifecycle, only the storage environment for whatever reason, but not necessarily their compute side of things. Or even within the compute side of things, they might choose to upgrade only one cluster because there's a security vulnerability affecting it or whatever the situation may be, but not the rest of the clusters in the environment. As we know, it's a complicated world out there. Getting change management, upgrade all these environments at the same time might be near impossible for some customers. So this allows them some flexibility to do sort of this one independent of the other. Another major benefit is licensing. In an HCI world, certain applications, if you will essentially theoretically enforce you to license every theoretical core on that HCI environment, right? Because a VM could theoretically run on any host in that HCI environment. This might be cost prohibitive to some customers, right? Because they might want to contain them. First off, right size these workloads, right? Because now I can have vSphere compute clusters right size based on application requirements. I can have a 2-node cluster attached into vSAN storage clusters. I can have 8, 10, whatever the node, just VCL limits at that point attaching to vSAN compute clusters. But the point here is it's based on the application requirements. And now if you want to contain that blast radius from a licensing perspective, I can have a 2 or 3-node vSphere cluster and license just for my applications. Therefore, I don't have a blast radius. Another important benefit is also from a lot of the large customers will choose to have separate, from your licensing perspective still, but a separate Windows cluster from its Linux cluster, again, because they want to have that isolation. Not theoretically very easy to do within HCI, but this is what disaggregation is for. But if you think more strategically, as customers are moving more and more towards a VCF, private cloud model, repatriating the resources more to a VCF centric sort of using VCF as a platform to deploy their private cloud model, the requirements include a variety of rich services these days, whether it be block, file, object, database as a service, containers, workloads running, whatever these things, right? It's becoming more and more complicated for these customers. And essentially these resources are running anywhere in the data center, right? And for that reason, some of these would benefit for running on HCI where it makes sense, and others would benefit for consolidation and centralized storage platform using vSAN storage clusters. Again, consumed at deployed anywhere in the data center, but consumed through some sort of catalog or ideally through your VCF automation. So yeah, there is a lot of unique use cases bubbling up within the context of there's a fundamental reasons why customers want to use it, and also a lot of interesting use cases coming up within the context of private cloud repatriation.
Yeah, I think those are very similar to what I've been hearing in Europe, at least from a use case perspective. Now, one of the other things that I've also noticed recently is that the interest for vSAN storage clusters has also ramped up probably over the last 12 to 18 months since a lot of people actually started adopting VCF. So maybe you can explain why that is for those who haven't noticed that yet.
Yeah, for sure. This has been a game changer for us, for sure. So again, first off, the VCF, our licensing portfolio itself has been dramatically simplified. Right? We only have a few SKUs now customers can choose from. Those SKUs are picked based on their requirements. But the beautiful thing, and vSAN, of course, is part of this, at least from a VCF perspective, vSAN is part of that VCF SKU. Important to note that VCF SKU and the vSAN used under VCF can be used however they see fit. But the beauty about this is for every core a customer purchases, every VCF core a customer purchases. Again, vSAN is included in that, but 1 TB of vSAN is included in that. So let's take a theoretical example of a customer who's got 2,000 cores in their environment. They purchase 2,000 cores of VCF. That means they get 2,000 TIBs or around 2 petabytes of vSAN included. They can choose to use that however they see fit, whether it be to deploy HCI. Let's say in a management domain, they have HCI cluster consuming some of those resources. They have another workload domain that has a vSAN storage cluster, provisioning storage to vSphere clusters, and another workload domain that has a vSAN storage cluster, provisioning storage to an HCI cluster. So essentially, it's extremely flexible on how customers can choose to use this. And since the licensing is now included as part of the VCF code itself, and customers are finding themselves with significant amount of capacity that they can harness upon, they're starting to think through also replacing their traditional storage environments with vSAN storage clusters where it makes sense. So yeah, this has been a game changer for us from a licensing perspective, and customers are understanding that, okay, I can use this for many, many more use cases and be flexible in how you deploy it, but operate and consolidate that centrally and manage that centrally. It's been a huge game changer for them.
Now, if I look at the platform itself, I think also what's part of introducing, or probably should say driving more interest into to the solution, is that we've introduced some new capabilities. Now, before we discuss some of those capabilities that we've introduced, I think the other driver for interest into the solution itself is the fact that we changed some of the hardware requirements. So it seems that we lowered the barrier for entry substantially. Maybe you could talk us through what that looks like today, because at first, when we first released vSAN storage clusters, or vSAN Max as they were called back in the day, we had some beefy requirements. So maybe you can go over them.
Absolutely. Yeah, this has been an area of focus for us for sure. First off, our overall goal is to, like you said, just simplify the hardware experience. I mean, of course, we don't do hardware, but the hardware requirements and experience from a customer perspective. Some additional goals that we had as a PM team is, how do we reduce the sort of the overall impact of hardware resources or cost anyway from a customer perspective as they choose to deploy vSAN. And secondly, also, there's a lot, especially in EMEA, I believe there's a lot of issues around, facilities costs, and power and cooling is becoming important. So we took that into our scenario as well, trying to understand, okay, how do we reduce this the best possible way and provide improve the total cost of ownership from a customer perspective. So the PM team took a data-driven approach to trying to understand how we can best remedy the situation. So we reviewed, hundreds of clusters, actual vSAN clusters that's deployed in the customer environments of varying sizes, varying data services enabled, varying hosts, and all these different, we covered the gamut on how they were configured and how they were utilized itself. And we, with the intention of trying to understand what is vSAN's resource consumption across these different usage patterns, specifically around CPU and memory. That was a primary goal. So what we found out is, there was room for opportunity for growth over here, opportunity to reduce those minimum requirements from a vSAN perspective, at least. So these new ready node profiles we introduced are squarely based on our research that we did from actual customer environments. So just to throw out a couple of observations here, a couple of reductions anyway that we performed. From a vSAN storage cluster perspective, we've reduced the memory requirements by up to 65%. Up to 33% reduction in CPU requirements for vSAN storage clusters, up to 50% reduction in memory requirements for vSAN all HCI-based clusters. So significant savings from a hardware cost perspective. There's actually a wonderful blog out there. We can post it out in your channel so customers can look at to understand sort of the thought process for this, so we can to explain to the customers why we did this, how we arrived at it, and where we're at right now. So now you factor in the fact that we have this, the VCF licensing, the one-tip vSAN that's included in the VCF licensing, all the space efficiency features we're bringing to bear, right? Deduplication, enhanced compression, all these things that are part of the product now, and reducing the hardware footprint for barrier to entry, as you put it, for these customers. It really should be, this is an overall reduction in total cost of ownership for the customers, and should be no reason for the customers to not look at vSAN holistically from a deployment perspective.
Yeah, I think that blog post is very useful, so I'll make sure to add that to the show notes of the episode today. And I'm pretty sure it was probably written by Pete Keeler, so I should be able to find it pretty
Absolutely.
easily.
Yeah, no problem.
Now,
Pete it is.
Exactly. From a functionality perspective, we've also introduced a couple of new features. And one of the features which I thought was huge is the traffic separation feature that we've introduced. Can you talk us through what that actually is and how it actually provides a benefit for our customers?
Absolutely, yeah. This is a huge, huge win for us. So you think about historically from a vSAN HCI perspective, right? There's first off, within the context of vSAN traffic alone, there's essentially two types of traffic at a very macro level. One is guest I/O. Basically, this is I/O to and from the guest and the storage, in this case vSAN. And the other one is vSAN specific IO. These are the IO that traverses vSAN nodes for purposes of ensuring data is in sync across all these nodes, resynchronization, replication, all that sort of heavy lift backend traffic. That's another thing. So this vSAN IO is typically called backend traffic or east-west traffic because it traverses just the vSAN networking. And the VM IO is typically called front-end traffic and is also known as north-south traffic. This makes sense in a HCI world where the VMs are co-located with the vSAN storage itself. So in that world, we had a single VM kernel port backing these two discrete traffic types for vSAN. But this makes less sense when you move to a fully disaggregated world where the storage is at least one hop away from where the compute node clusters reside. So we looked at this as a problem and trying to figure out how best to solve it. So essentially where we landed is to separate these two traffic types. By that, what I mean is north-south traffic will be backed by its own vSAN VM kernel port tagged for external traffic, and will have it be backed by its own PNICs, and east-west traffic, more of the heavy lift traffic, will also be tagged for, just for that purpose, will be backed by its own PNIC, but also have its own VM kernel associated. So now so what are the benefits? What are the observed benefits from doing this? First and foremost, performance. Well over 35% improvement in performance for a vSAN storage cluster when compared to not separating these two traffic towers. So that itself is a big win for our customer perspective. Next, it provides some level of flexibility in your network topology. Imagine, if you will, your customer has 25 gig networking everywhere, but they're going to deploy a pretty heavily dense storage cluster. So they want to make sure that east-west traffic alone is, they have no issues with throughput or performance or whatever it might be. So they want to separate that out. So they could end up with an environment, let's say you have 10 nodes in a rack. They could end up with an environment where they have a couple of 100 gig switching just private to that rack alone, just consuming whatever it needs for the east-west traffic, whereas a north-south traffic could be 25 gigs if that's what the customer's core networking is. So it brings a lot of flexibility in sort of the network topology, network configuration, so as to not have to whole-scale upgrade your entire network just because you need a couple of clusters over there requiring higher bandwidth. And finally, of course, because you're sort of separating these two traffic types, there's an inherent level of security enhancement too, because you're keeping these two discrete over VM kernel ports, discrete over its own PNIC. So overall, this has been a huge win from our perspective.
Yeah, I think especially from a efficiency perspective, I didn't realize that the performance gain was that much, and I think that is huge. And of course, also the potential cost reduction, having to avoid needing to upgrade the whole environment to 100 gig, is significant for the majority of customers. Now, one of the other things which I was very excited about, being from Europe, of course, is the stretched cluster configuration that we now support. And I think this is something that is fairly unique. So maybe you could talk us through what we've introduced into the platform, because I think it's a really cool feature, which especially European listeners will appreciate.
Absolutely. Yeah, we had our European partners and friends in mind as we were going through this as well, for sure. So if you think about just stretch clustering in general, has been around for a long time, well consumed, of course, as you put it in EMEA. When we announced vSAN, disaggregated vSAN, we also had support for stretching the storage cluster, right? But in an HCI world, of course, all this is collapsed, and HA knows what to do when there's an issue with one of the two fault domains or sites that in a stretch cluster. But until 9.0 anyway, again, going back to what we discussed earlier about who consumes storage from vSAN storage cluster, right? There are essentially two entities. Either you're a compute-only cluster or you're a HCI-enabled cluster. Setting aside HCI-enabled cluster for a second, the compute-only cluster is a vSphere cluster, essentially, but it doesn't understand the notion of a fault domain. So if you stretch a storage cluster across two fault domains, across two sites for resiliency purposes, and you have these two vSphere clusters essentially split between, or a single vSphere cluster essentially split between these two sites, it didn't understand that I was in fault domain 1 versus fault domain 2. That's what changed at 9.0. We provided we had vSphere clusters learn the notion of a fault domain essentially. So it now realizes, okay, I'm here versus I'm on the other fault domain. A couple of inherent benefits to it. First off, from just a network IO perspective, right? I make sure to send IO to resources that are local to my environment and not have to traverse the ISO, latency implications, whatnot. And second, what probably most importantly is full resilience, right? Any part and piece of this within a fault domain could fail, or the entire fault domain could fail. and HA is aware of what's going on, will make sure all those resources are brought up on the surviving member, surviving vSphere cluster on the secondary fault domain, and you're up and running. Now, within the context of traditional storage, this has been around for a while, where customers engage with this synchronous relationship between two traditional storage environments, and they had to go through this complicated process to set up. It's called vSphere Metro Storage Cluster, VMSC. All that has gone away with this support. It's very simple, just like you would stretch it. There's of course some planning that needs to be done, but from a execution perspective, creating a stretch compute cluster to attach to a storage cluster is extremely simple without any complication.
Yeah, it's interesting because I spoke to a customer not too long ago, and one of the things that they said is that if they look at vSAN itself and whether it's vSAN HCI or vSAN storage clusters, setting up a stretch cluster configuration usually takes 10 to 15 minutes. Having a discussion with the networking team usually takes multiple days, so that is typically the blocker. Now, I also invited you not just to talk about new technology, but I also recently saw a blog post which I thought was very interesting. We released a use case and a pretty big customer name of a customer that actually adopted vSAN storage clusters in a significant way for a business critical use case, I have to say. So I'll let you introduce the use case, and I'll let you introduce the customer, because I thought it was very interesting, and I think a lot of listeners will also be interested in hearing who it is and what they've done.
Absolutely, yeah. No, thanks for bringing this up. Yeah, this is a true partnership and a much macro level partnership between Broadcom, of course, and Audi. Audi was into the process, has been for a while now. They're of course a pioneer in car manufacturing. I've loved their cars all along. They had a goal, a multi-year goal, to sort of transform their factory automation. And one of the like the tenets to pursuing that is to go to a fully software-defined approach, which we take for granted, of course, within the context of our data center environments. Virtualization has been around forever. Software-defined everything has been forever. But these are very mission-critical style environments where downtime is just completely unacceptable. So they were moving slowly towards a fully software-defined platform for their manufacturing facilities. They have, of course, multiple goals, but just to narrow in on at least where vSAN fit, there are a few sort of critical goals. One was they were trying to improve their time to market. And by that, I mean new features and functionality that they bring to bear from an application perspective. They should be able to bring it back, but bring it to market much faster than they ever be able to. Two, of course, which everyone has, is they want to reduce the impacts of any sort of downtime associated with these environments. So unplanned downtime, especially, or planned, but even more specifically on unplanned downtime, they want to minimize the impact of any of that on their manufacturing lines. And finally, of course, which customer doesn't want to do this? They're trying to improve their total cost of ownership, reduce their costs across all their different manufacturing facilities. So that as a premise to why we engage in a partnership with them at a very high level. The solution essentially leverages all parts and pieces of vSAN. That's the beauty about it. But again, going back to the operational simplicity, right? But it uses, so picture, if you will, there are two data centers, each with a vSAN HCI cluster deployed in it. Those HCI clusters act as essentially VDI environments for the users coming in. And then they also have a stretched storage cluster across these two data centers. So therefore, two fault domains, each side of the fault domain mounted to each of those HCI clusters that's used for VDI. So the ephemeral data essentially comes to the VDI environment, basically session data that's just required login specific data, and all the persistent data is coming from the storage cluster itself. And persistent data in this case is sort of specifics around what's happening in the manufacturing line, where should it be going first. So, imagine, if you will, an engineer is coming in to do something to one of the cars, like he's trying to figure out what next to do. So he logs into this VDI environment, which is, it's ephemeral data, it gets the session information, all that. And as part in the background, that storage cluster in that single fault domain is mounted to that particular VDI environment. Just at a super high level, I'm not going to go into detail, but a super high level, what this, like, for example, say, okay, you have to go install this next fender or next whatever on this car. So he goes and does that. Everything during normal operations, no worries. It just continues on in its merry way. Let's say, for example, there's an outage on that data center or the primary fault domain. All this, in this case, all the user has to do is just log back into this surviving HCI cluster in the second fault domain, which is its own discrete HCI deployment, logs in, gets the session data, but again, there that storage cluster is mounted locally. This, by the way, is across VCF boundaries. That storage cluster is mounted locally to that HCI environment and has his session-specific data, the persistent data, immediately available to him. So he relogs in there, he knows, okay, well, I did the fender already, now I got to move on to this next partner piece. So this overall thing significantly, made this entire process easier for them, made it resilient towards discrete outages in each one of these sites, and they deployed essentially all vSAN has to offer in this VCF deployment, manage it centrally, and lifecycle centrally. So this is just beautiful for them. So this solution worked out perfectly for them. Just to paraphrase what one of the domain architects mentioned over there, they said this solution helped them speed up delivery of new features, implement the solution much faster, and benefit operations by reducing downtime. So this is a quote from one of the blogs. So we can also put those blogs out there if your users see fit.
Yeah, I think the downtime aspect is big. I mean, we've all seen the news not too long ago where one of the car manufacturers was actually hit by a ransomware attack, and they were down for I don't know how many weeks, and there were hundreds of millions of dollars of downtime cost involved as a result. So I think it's pretty fair to say that when it comes to these car manufacturers, that this is core to their business right now. If you look at what they've actually done, I think it's really interesting because they've adopted both the HCI model as well as vSAN storage clusters. And of course, we've seen a lot of customers actually going down the HCI path, but we haven't seen as many customers going down that whole vSAN storage cluster path. So maybe you can talk us through what some of the decisions were around this and why they actually made that specific decision to both use vSAN storage clusters as well as the HCI solution itself.
Yeah, absolutely. I mean, from this particular perspective, it was more about providing resiliency into the entire environment, and any discrete failure shouldn't cause a failure in the manufacturing process itself. So it was very important, and more importantly, they wanted to have this as simple as possible, because in the manufacturing facilities that that's not where the core data centers are probably running. They needed to be deployed as simple as possible. But let's step back for a second and sort of understand the storage implications as customers are going through this, designing and bringing up their private cloud platform itself, right? They just, they're requiring a variety of different deployment options, whether it be HCI or DHI. We got that covered from that perspective. Now you step up a little bit, their applications are demanding different protocol types too, different types of access, the way they access the data, whether it be block, file, object. So there's just more and more complexity being added to this environment. And you layer on top of that the applications that are being used or consuming these, whether it's HCI, DHI, whether it be file, block, or object, there are your traditional VMs, you have your container-based workloads, you have workloads that are a combination of traditional and container, and you have database as a service, you have data protection VMs, you have a lot of these deployments in your environment. Right. So, and these all need to be consumed in a simple way, through a catalog of services. At the end of the day, it depends. What my point here is, at the end of the day, it depends on what the use case and workloads are, and finding a proper fit for these particular use cases. Customers are always going to have both HCI and DHCI in the environment, right? Today, case in point is no different. Today, they have HCI in their environment backed by vSAN. They might have a traditional storage area in their environment. So they're always going to have that sort of split between the two. The point here is, you want to consolidate that down to make it simple to operate and manage, not take the complexity out of this environment, but maintaining operational consistency between whether you deploy HCI or DHCI environment to satisfy your application requirements. Right. So, but the beauty about deploying vSAN storage clusters and HCI is also, we understand in large customers they have, could have these siloed operational model where they have compute, network, and storage teams where that might not be a super good fit for HCI workloads. Operationally, vSAN storage clusters make perfect sense there, right? Because I can have a VCF deployment has nothing but vSAN storage clusters, or workload domains that have nothing but vSAN storage clusters. That is behind like a VCF or VC boundary managed by the storage team, and have compute clusters managed by a completely different team. So operationally, this mold falls well within our customers' operational model as well. Some customers also have, storage outsourced, for example. Again, this fits well within with that sort of an operational model. So, and then I believe we also had a conversation about vSAN over fiber channel in a podcast not too long ago. That's all fully disaggregated, right? It's essentially vSAN storage clusters communicating over fiber channel network to compute clusters somewhere. So as we move into this new sort of private cloud deployment model, again, the choice is for the customer, but the simplicity and removing complexity out of the environment is all based on vSAN backed deployments.
Yeah, it's funny because the very first time started talking about vSAN storage clusters, or vSAN Max as it was called back in the day, and people brought up the operational model. I never understood it. I'm like, are you guys still not talk to the storage team and to the networking team? But that seems to be the case, right? They're still very much segregated. So from that point of view, I can understand why it's interesting to use this model as well. Now, the other thing that I've also noticed is that one of the use cases that comes up regularly with customers when it comes to vSAN storage clusters specifically is the whole ransomware discussion, and of course the immutable snapshot capability that we introduced not too long ago. Now, is this something that you hear coming up with customers as well? And for those who have never heard about the use case, maybe you can also explain what the use case is for customers that may be interested in building a ransomware recovery solution.
Yeah, no, this is top of mind for everyone, right? They don't go by the news every other week. There's something or other happening in this space for sure. Backup and recovery there's, if you think about just storage clusters, which I feel is a good fit for all use cases, and broadly, these use cases can be broken down into primary or secondary use cases, right? Primary being your production core workloads, also your disaster recovery, right? I see primary and secondary, your production workloads and disaster recovery workloads as essentially the same, because there's an expectation of a performance. Should an application or environment go down, you want to make sure that it's consistent on the other side. Now you talk about secondary use cases, which is what we're talking about here. Secondary, there are several use cases, but what I want to focus in on is a backup use case, of course, which vSAN storage clusters are a perfect fit for, which is basically, your primary data gets replicated over to your target site, and you have it there. It's like an insurance policy, of course. But more importantly, it's the cyber recovery use cases. And this, of course, we're having a lot of conversations with customers on this, being able to protect the data in a more cost-efficient manner, being able to bring it back in the event of a ransomware event with the least amount of time taken to do so. Again, this is a good fit for vSAN storage clusters because, one, you can deploy vSAN storage clusters in a siloed area, in a different data center, different city, whatever, replicate that storage over there. It can be heavily densified environments, highly scalable environment, where you sort of have this many-to-one approach, meaning many client nodes, client clusters, client sites, whatever it may be, replicate to this single storage cluster, where for those workloads that you choose to enable immutability on, which basically means, it's nobody can destroy that particular snapshot that was taken. It can be used only, in the event of some sort of an outage, some issue, or in this case, a ransomware event, where then all that the customer has to do at that point is, they probably have a couple of vSphere clusters sitting over there, attach it to this particular storage cluster. In the event of a ransomware event, they go through the ransomware use cases, which basically looks to see the entropy of the data, meaning they're going back to see when it is that, some sort of encryption event or some sort of event happens. So they go back to the point in time where they can successfully recover that data, right? And then now I want to push that data back to my production site, but I don't want to have to push all the data back to my production site as well. I just want to make sure I send back the relevant blocks of data. So with the intention of being able to bring this back up just as quickly as I can, right? So we see this as a very common talk track. I believe data, centralized storage, traditional storage, whatever you want to call it. But from my perspective, vSAN storage clusters, the conversation is incomplete unless you talk about data protection and specifically cyber recovery and ransomware recovery. So yeah, this is a common use case for us, and we see a lot of interest in customers from this perspective.
Yeah, for those who are interested in that solution and who happen to be at the VMware Connect event in Amsterdam, I'm actually going to show a demo of the whole ransomware recovery workflow. So if you're there, make sure to attend the keynote that I'm doing. Now, Kalyan, before I let you go, any famous last words or any final thoughts you would like to share with the audience?
Yeah, for sure. As a lot of our customers, as we discuss, are going through this private cloud journey. They're repatriating their workloads from public cloud to private cloud, or just building a private cloud to bring agility in their data centers, agility to be able to spin up whatever type of applications that they need to, to service the lines of business, right? Whether it be developer, DevOps user, whoever this user might be, would customers going through this process of building this private cloud environment. What I want to leave your listeners with is the following, right? So we've already discussed the benefits of vSAN storage clusters, the benefits of the vSAN in general, whether it be HCI or DHCI for a customer environment. I want them to think through vSAN storage clusters as sort of from a top-down approach as they're building their day zero, greenfield environment for VCF to enable their private cloud model. In lieu of other traditional storage options, right? Think about vSAN storage clusters sort of central to your design, as opposed to sort of an afterthought, which most of customers are looking at it more from a point solution, like what was originally called the HCI mesh world, where they're just augmenting storage between two HCI clusters. Instead of think about it that way, we want you to think vSAN, of course, central to your VCF deployment, but vSAN storage clusters as sort of a focal point or top-down approach to being able to build a disaggregated storage deployment for your customers. You combine that with vSAN storage clusters with HCI, ESA, and all the critical services we offer, whether it be file, block, object, data protection services, resiliency services, database as a service itself. This becomes central to what a customer would do from the perspective of their VCF strategy.
And that's it. Thanks for tuning in to the Unexplored Territory podcast. If you enjoyed this episode, don't forget to subscribe and leave a review or rating wherever possible. And please join us again next time as we cover more insights into cutting-edge solutions shaping the world of IT. Until then, stay comfortable, keep exploring.